Here the question is that a 10-gram bullet having a charge of 4 microcoulomb is fired at a speed of 270 meter per second in a horizontal direction. The vertical magnetic field of this exists in the space, and find the deflection of the bullet due to the magnetic field as it travels through 100 meters. Make its approximation. Okay, let's understand what is in this numerical. What we have to understand: a bullet is fired and along the horizontal direction it has some charge. Due to this charge and due to the moving charge, as it is fired with some speed, that means it is a moving charged particle, and that's why if magnetic field is present here, the vertical magnetic field also present in the space. So here the magnetic field is present and a moving charge, that means it will experience a magnetic force. And what will be the direction we have to find out, and then how the deflection process will happen. Because of this force, because of this magnetic force, some deflection will happen in this bullet. So let's think for this, for the direction, what will be actually. Now the magnetic field is along the vertical direction, and the speed of the bullet is along the horizontal direction. If we direct the thumb along the V vector and B is along this, then the face of this palm, that means towards me, it is the force. So it means that if velocity is along this direction and magnetic field along this direction, that means the deflection is like this. Means if it is like this, if V is this and vertical, completely vertical direction is for the magnetic field, then it will deflect like this along towards this direction. So what it means, when it will travel some 100 meter, it is given here that when it is traveling 100 meter for in this direction, there is deflection towards this side, and we have to find out this deflection. Let's denote it as 2t square. Now we have to find out the value of it is from along this direction, there is no initial velocity, so it is just 0, and we have to find out s equals to half a t square. So that means we have to find out the acceleration, and we can find out this acceleration by using the force formula, magnetic force formula. F equals to q into v cross b, and force equals to mass into acceleration. Then we can calculate the acceleration. And what is the time? When the bullet is traveling this 100 meter along the horizontal direction, that time also, because of this force, it will deflect towards this side. That same time, that means here if for 100 meter it takes x by v, what it means? X by v, x is given 100 meter and v is given 270 meter per second. That means t is equals to x by v, and we can find out the value. Now we have to find out the acceleration. That means the force, magnetic force equals to q into v cross b. Here velocity is given, velocity along horizontal direction, and b is along this direction. So the force is along this, towards this direction. So, and v and b are perpendicular to each other 90 degrees. So sine 90 is sine 90 is 1. So simply we can find out the magnitude of force, that is q into vb. Sine 90 is 1. So we can find out the acceleration also, that is q vb by m. So we are getting acceleration value, time value, and we can put it here. So let's put the values and get the answer. Here S equals to half into q vb by m into x by v whole square. That means half into q b x square by m v. So half into the charge, that charge is given, how much it is in this question? The charge is given 4 microcoulomb. 4 microcoulomb, that means 4 into 10 to the power of minus 6 coulomb. B is given magnetic field 500 microtesla. That means 500 into 10 to the power of minus 6. X distance is given, it travels 100 meter. So for 100 meter, 100 square divided by the mass into velocity. Mass of the bullet 10 gram and velocity is given 270 meter per second. So 10 gram and 270 meter per second. For 10 gram, 10 by 1000 kg, that is in SI unit, and 270 meter per second. So calculate these values and you will get the value. It will be approximately 100 by 27 into 10 to the power of minus 6. Approximately, its approximate value 3.7 into 10 to the power of minus 6. This is the answer. Thank you.